Back in the late 1970s and early 1980s, General Motors made what looked like a bold move. They put a diesel version of their 350 cubic inch V8 into passenger cars. It wasn't some exotic import engine. It was their own 350, or rather a dieselized version, reborn to deliver better fuel economy in a time when gas prices were sky high and efficiency was everything. But what sounded so promising ended up being one of the most damaging decisions in American automotive history. GM's 350 diesel, often referred to as the Oldsmobile 350DX or LF9, didn't just fail. It torpedoed public trust in diesel engines across the US for decades. The genesis of this engine goes back to the oil crisis. Automakers were scrambling to provide better fuel economy, and diesel was the obvious answer. Diesel engines were already well known in Europe. They were efficient, torquey, and built for longevity. GM's solution? Take a proven gasoline V8, the same small block architecture that powered muscle cars, and re-engineer it for diesel. On paper, it made sense. Same displacement, predictable manufacturing lines, a lower cost development path. In reality, it was a disaster. Mechanics who looked under the hood were skeptical from the start. The Oldsmobile 350 diesel was built on a gasoline engine block that was never really meant to handle the high compression and forces of diesel combustion. According to many sources, GM reinforced the internal parts, pistons, rods, crankshafts, to handle the added stress. But those reinforcements were never enough. Problems started mounting quickly. Blown head gaskets, cracked blocks, poor fuel system design, and the absence of a proper water separator to handle moisture in diesel fuel. Water in the fuel became a huge issue. Back then, diesel quality varied a lot, and condensation frequently got into fuel tanks. Without a reliable water separator, engine internals would corrode, seals would fail, and injectors would go bad. Some owners resorted to desperate measures, pouring anhydrous alcohol into their tanks to try to keep water from fouling the system. That, of course, led to even more problems. Rubber system parts deteriorated and everything got less reliable. Timing belts also became a weak point. While other diesel engines used timing chains, GM's 350 diesel used a rubber belt. That was a strange choice, even at the time. Rubber belts stretch, especially under high loads, and when that belt slipped or stretched, serious damage followed. Timing jump incidents weren't rare. The belt could literally lose synchronization, messing up the valve train and causing catastrophic engine wear. By the time reliability issues became obvious in the real world, public perception had already soured. Word of mouth about frequent engine failures spread fast. Mechanics refused to touch them. The owners complained. Even when GM made engineering tweaks, stronger heads, redesigned fuel pumps, it wasn't enough to save face. Sales may have peaked, but the damage was done. Buyers began associating anything labeled GM diesel with unreliability. It didn't help that the engine was slow either. Unlike efficient, purpose-built diesels, the 350 diesel felt underpowered. It lacked the torque punch that people expected from diesel, and the refinement wasn't great. That combination, poor reliability and mediocre performance, killed confidence. Enthusiasts and everyday drivers alike started writing off GM diesel as a gimmick. Some just had to avoid it altogether. Greater than that Oldsmobile made diesel-powered cars single-handedly ruined the reputation of diesels for passenger cars in America for a very long time. By 1985, GM pulled the plug. The Oldsmobile 350 diesel line ended, but its legacy lived on. According to reports, by the time GM stopped production, they had redesigned enough to make the engine reasonably reliable, but it was too little, too late. The reputational damage stayed. In the wake of the 350 fiasco, Americans soured on diesel in their cars. Even though other diesel engines existed, the memory of those failing Olds V8s hung over the market. GM's diesel experiment had frightened consumers, and that fear lingered through the 1990s. Diesel in passenger vehicles would only make a cautious comeback much later. Compare that with what GM did right later. The 6.2 and 6.5-liter Detroit diesel V8 engines, for example. These engines were designed from the ground up for diesel duty. They served in trucks, SUVs, even military vehicles, and generally earned a reputation for dependability, despite some flaws. But the damage to GM's small engine diesel image was already done. Fast forward to modern times. GM's diesel legacy today lives in the Duramax V8 engine, which has been a major player in heavy-duty trucks since 2001. These are proven, reliable, high-performance engines, but they belong in trucks, not passenger cars. The trust issues from the 350 diesel era undoubtedly played a role in GM keeping diesel power focused on work applications. Some automotive historians argue that the 350 diesel didn't just fail, it set the entire American diesel passenger car industry back by decades. Worldwide, diesel was thriving in Europe, powering everything from family sedans to commercial fleets. But in the US, GM's failure shoved diesel into a niche role. It became a fuel for trucks, not for family cars. And that shaped the trajectory of diesel technology for a long time. There's also a human side. Many GM engineers knew about the risks. According to some insider accounts, staff raised serious concerns early on. Issues like crankshaft failures and cracked blocks showed up in testing, but time and market pressure pushed the engine forward anyway. That kind of rush to market is often the root of engineering nightmares, and in this case, it backfired spectacularly. Online enthusiasts and mechanics still talk about the 350 diesel legacy. On Reddit, one veteran diesel owner put it bluntly, "This engine ruined the diesel market in the US." People rebuilding these engines today often do so just to salvage parts or convert them back to gasoline because of how problematic they were. Yet, even with its flaws, there's a twisted respect for the 350 diesel's block. It was built tough, and when properly rebuilt, it could be repurposed. Some gearheads salvage the strong cast iron block for hot rodding or custom builds. In other words, while the engine was a flop in its original form, parts of it still get second life today among those who appreciate its raw mechanical DNA. Early on, GM's engineers identified the weak points. The cylinder heads were prone to warping under high compression. The head bolts stretched, leading to gasket failure, and the fuel injection system, adapted from a cheap rotary design, couldn't deliver consistent pressure. Even worse, GM didn't fit an adequate water separator or fuel filter, both crucial in diesel systems to remove moisture and contaminants. And American diesel fuel in the 1970s wasn't clean or standardized the way it is today, so water and dirt went straight into the pumps and injectors, quickly corroding them. Within months of release, customers began complaining. Brand new Cadillacs, Oldsmobiles, and Buicks with the diesel option were breaking down before 10,000 miles. Dealerships were overwhelmed, warranty claims piled up, and soon lawyers got involved. GM ended up in multiple class action lawsuits, forced to buy back cars or cover expensive repairs. The company quietly modified the design several times. The DX, DXA, and DXB versions were supposed to be stronger, but the stigma never went away. Even those who owned the improved versions didn't trust them, because by then, the damage was already done. There's an important psychological lesson here. In engineering, mistakes happen, but when customers feel betrayed, the fallout can last generations. People who had their cars fail didn't just swear off GM diesels, they swore off diesel entirely. For many Americans, diesel became synonymous with unreliable, dirty, and loud. That perception persisted well into the 2000s. Even as European automakers refined the technology with turbocharging and clean emission systems, the US consumer base remained skeptical. It's also worth noting that GM wasn't the only one experimenting with diesels. Ford and Chrysler also dabbled in diesel cars, but they either sourced engines from proven diesel manufacturers like Mitsubishi or kept their volumes small. GM, in contrast, went all in. They installed the 350 diesel in millions of vehicles across multiple divisions: Oldsmobile, Chevrolet, Cadillac, Buick, and even GMC. That scale magnified the backlash when things started going wrong. The ripple effects reached deep into the American automotive psyche. While Europe embraced diesel in passenger cars, with models like the Mercedes-Benz 300D becoming icons of durability, Americans went the opposite direction. They associated diesel with broken head gaskets and clouds of smoke on cold mornings. The idea of a diesel luxury car became almost laughable. Cadillac's image in particular suffered. The brand's prestigious Fleetwood and Seville models, once symbols of American luxury, became punchlines. From a corporate perspective, GM's decision was understandable but ultimately short-sighted. The late 1970s were a turbulent time. Emission standards were tightening, and efficiency was king. The federal government was pushing automakers toward better corporate average fuel economy ratings. GM thought the diesel 350 would be their ticket to compliance without redesigning their entire lineup. But when reliability plummeted, the opposite happened. Sales collapsed, warranty costs exploded, and consumer trust vanished. In the engineering community, the GM 350 diesel became a case study in what not to do. You can't simply convert a gasoline engine to diesel without rebuilding it from the ground up. Compression forces, lubrication needs, thermal expansion rates, they're all different. The materials, tolerances, and machining precision required for a diesel engine are far more demanding. The old 350 diesel lacked that refinement. It wasn't purpose-built, it was improvised. One could argue that GM's biggest mistake wasn't mechanical, it was cultural. Instead of admitting early on that the project was flawed and starting fresh, corporate leadership doubled down. Fearing the embarrassment of public failure, engineers who warned about potential issues were reportedly ignored or overruled. In the end, the company spent more trying to fix a broken concept than it would have cost to design a proper diesel from scratch. When GM finally stopped production in 1985, it quietly buried the project, but the damage lingered for decades. For many Americans who lived through the era, the words GM and diesel in the same sentence still evoke groans. It took GM nearly 2 decades to fully re-enter the diesel market with the Duramax series, this time developed with Isuzu, a company that actually knew how to build reliable diesel engines. Interestingly, the 350 diesel wasn't a total loss mechanically. The reinforced block, though plagued with gasket and head issues, was actually quite strong in its lower half. Hot rodders discovered that these diesel blocks made an excellent foundation for high-performance gasoline builds. Because they were thicker and more rigid than the standard gas blocks, they could handle extreme horsepower once converted back to gasoline use. In a strange twist of fate, an engine that failed spectacularly as a diesel found redemption in the world of drag racing. So next time you see a gleaming Duramax-powered Silverado or a heavy-duty GMC Sierra hauling effortlessly down the highway, remember the dark chapter that came before it, the one that nearly killed American diesel. Without the pain of the 350 diesel, GM might never have learned what true durability and engineering discipline mean. In a strange, roundabout way, that failure paved the road for the diesels that did succeed. If you found this history dive fascinating, hit that like button, share with a friend who loves engine stories, and subscribe for more deep dives into the machines that shaped automotive America. The 350 diesel may be gone, but its lessons are still driving us, even today.